Hey guys, what's up? Welcome to TSK Tutorials, and this is FPS 1.31. So in today's episode, we're going to learn how to make stairs. So it seems like it would be really simple to make stairs, where you just create cubes, or a cube, another cube, another cube, another cube, and you make stairs that way. But if you've noticed, the capsule is not very good at walking up and down stairs. We need to create some smooth movement of the camera, or of the capsule going up and down the stairs. And I did show in one of my previous tutorials on how to do this and how to create a smooth ramp motion to the stairs. And the way you do that is that all of the cubes have both colliders and renderers attached to them, and we can turn those both on and off. When we turn the renderer off, the game object is still working, but it's just invisible. And then when we turn the collider off, the game object is still visible, but when we walk up to it, it has no physical contact with the player. You can just walk straight through it. So we're going to be using these two things to create some stairs. So first of all, we're going to create all of those cubes to make the separate steps, or you can import this in an actual model. And then for that, we are going to leave the renderer on, and we're going to turn the collider off. And then what we're going to do is we're going to create another cube that we're going to lay on top of these. So imagine this as, say, a really long piece of wood that you just lay on top of the stairs. And then what we're going to do with that is we're going to leave the collider on and turn the renderer off. So that means the stairs that we can see, we can't actually interact with. And then the big cube that's just lying over top of the stairs, it's just long and smooth and basically a ramp, we can't see, but we can interact with. So now we have some stairs that look jagged and like real stairs, and then we have an invisible ramp that the player will be able to interact with very smoothly. But this leads us to one more problem, and that is the fact that it literally is a ramp. So when you go running up it and you gather up speed and you get to the very end, if you guys noticed before, you kind of fly off of it like an actual ramp, and it's really hard to control. And in order to get around it, you have to purposefully slow way down once you get to the very top of the stairs, and you have to like inch your way over so that you don't just fly over like that. And then we have another problem going the opposite direction. When we actually do want to go down the stairs and we start running, the player just goes forward and flies over the entire set of stairs, when really we want them to go up to the stairs and then walk down them. So the way that we're going to fix this is we're going to be creating two triggers with tags. I believe I set them as stairs going up and stairs going down. But the way that we're going to do this is we are going to check the direction in which the player is moving and see if it is in the same general direction as the stairs going up, and if so, we are going to, at the very top of the stairs, we are going to set the player's vertical movement to 0 so that the player can't ramp off anymore. It can only go up and then forward. And then we're going to do the opposite thing with the stairs going down. So we're going to put another cube at the part where the stairs are going down, and we're going to have this cube's forward or z-axis pointing towards the downwards motion of the stairs. And if the player comes in contact with this and it is already moving in the general direction of the stairs going down, we're going to add a downward force to the player's rigid body so that the player doesn't ramp off that way as well. So let me show you how to do that in code, and we're actually going to be doing this all inside of the player movement script. Alright, so today we're actually not using any variables, and we're putting all of our code inside of function on trigger stay right alongside of the code for picking up ammo. Alright, so first of all we have function on trigger stay, and in these parentheses here we have the variable hit trigger, and that is of type collider. So this is going to return us the collider in which we actually collided with, or the collider that is set to be a trigger, so it doesn't actually interact with the physics engine. Alright, and then the first if statement we have inside of onTriggerStay is if hitTrigger.transform.tag equals stair going up. So basically we're going to, for the invisible cube that is set as a trigger, we're going to give that a tag of either stair going up and stair going down, and we're going to place those accordingly on our stairs. And if the tag is stair going up, then we are going to execute the lines of code that are going to be for if the player is walking up the stairs. Alright, so our next if statement has two conditions inside of it. And the first condition is if input.getButtonJump equals false. So if the player does get to the very top of the stairs, or maybe they're camping at the top of the stairs, we don't actually want them to not be able to jump. So we're just going to do if the spacebar has not been pressed, then we will execute the next lines of code. But if the spacebar has been pressed, we do want to allow the player to be able to jump. So we will just only if the spacebar is not being held down, we'll execute this next line of code. And then the second condition inside of this if statement is going to compare the direction at which the player is moving and the direction at which this cube is facing. So we're going to place this cube, or the stair going up game object, we're going to have it pointing towards the direction the player will be going after they reach the very top of the stairs and they continue to walk forward. So we're going to compare the angle with vector3.angle. And then the first vector 3 we give it is simply rigidBody.velocity. So this is the movements of the player and the velocity and the direction in world space at which they are moving. And then we are going to compare that to hitTrigger.transform.forward. So this is going to be the forward direction of the invisible cube with the tag stair going up. And if it is less than 90, then we'll execute the next line of code, because if it is more than 90, then the player is pretty much moving in the other direction. But if it is less than 90, it's going in the same general direction. And if it equals 90, then we're going horizontally compared to the stairs, so then we don't really need to worry about that so much. So just if it is less than 90, we'll execute this next line of code. Alright, and then very simply we have one more if statement that is if rigidBody.velocity.y is more than 0, and if it is more than 0, then the player is moving up, because remember when we do jumping, we are adding a positive velocity to the player on the y-axis. So if velocity.y is larger than 0, we're going to set rigidBody.velocity.y to 0. So these two lines of code are just going to limit the y velocity so that it can't go larger than 0. So this is going to limit the vertical motion of our player so that now we no longer have this ramp effect where we fly up into the air. Alright, next we have if hitTrigger.transform.tag equals stair going down. So now the player is walking down the stairs. And so here are the stairs right here, and you're walking, and you think that you just go down like this, when in reality, if you have a lot of speed, you're going to fly forward and you're going to jump over the stairs. So we're going to place a game object right in this area so that the player has to pass through that, and when it does pass through that, it's going to push it down and give it some velocity downwards so that it continues to go along down the stairs in a normal human-like way. Alright, so now that we have this if statement that determines whether or not we entered into a trigger with the tag stair going down, we need to double check to make sure that we are actually moving in the direction down the stairs. And then we also, once again, are just making sure we're not pressing the jump key. So if we are hitting the jump key, we are going to allow the player to jump, and we're going to cancel out all of this stuff and allow the player to jump normally. But then we have if vector3.angle, rigidBody.velocity, hitTrigger.transform.forward is less than 90. So exact same thing as we have up here. Just want to make sure that the movement of the player is in the same general direction as this cube is facing, so that we know the player is going down the stairs and not up the stairs. And then if we determine that the player is going down the stairs, we're going to do rigidBody.addForce 0, -100, 0. So this technically isn't really the best way to add force to the rigid body, but it doesn't really matter so much. I mean, we could probably set this to a number as large as 1,000 or 500. You can experiment with how large the number can be, also depending on the mass that you set your player to. But I found in my game 100 is a pretty good number and should be a very good general number because we just want to quickly push the player to the ground so that they continue to go down the stairs. So that they don't ramp off the stairs. So yeah, we're just going to be adding a downwards force to the player if they are going in the direction down the stairs. So instead of flying off like this, they go here, add force, they move down the stairs, and from there on they pretty much just stick down the stairs. And then here I have a commented outline of code that just says code for picking up ammo, and this represents all of the code that was already inside a function on trigger stay for picking up ammo. Alright, so that's everything you need to know on how to make proper stairs and make them work properly. But there's one more thing I want to mention that's kind of off topic, but also inside of the player movement script, so I thought I'd throw it inside of this episode. And I want to change a line of code that I have over here, and this is the couple of lines of code that determine or that we get the horizontal and vertical input axes for our player, but basically these are the lines of code that make our player move. And if you remember in earlier episodes, I added a multiplied by time.delta time inside of there, but I recently read some text inside of the Unity script reference, and as it turns out, I was doing that totally wrong. Whenever you want to constantly add force to a rigid body, you want to put it inside of fixed update. And the way fixed update works is that fixed update is actually going to happen at a certain interval of time in the game, as opposed to update where it just happens as fast as the computer can actually keep on updating. And fixed update happens like, say, once every 30th of a second. So we want to put these rigid body.addRelativeForce functions inside of that. So we're simply going to move all of this code inside of function fixed update, and then we're just going to delete the multiplication of time.delta time, and then this is going to make our player move with a lot better control, in my opinion. It's a very subtle difference, but I think it makes a big difference and makes the character more easy to control. And also inside of Unity, I'm going to give you guys a few tips on how to very precisely edit the movement of your player and make it feel just right. One of those things is going to be adding a physic material to the player, and I'm going to show you how to do that inside of Unity. So yeah, I guess that's everything I have to say. So now I'm going to cut the green screen and go into Unity and show you how to do that inside of Unity. Alright, here we are inside of Unity, and let me demonstrate the stairs that we have right now. So you guys saw me make this in another episode. So the actual step cubes, which you can see right here, the collider is turned off on them, and there's an invisible cube running up them. So when I go up them, it actually works. And let me give you a better demonstration. Let me run full speed up these stairs. Woo! And I just fly off. That doesn't work at all. And let me show you the opposite way what happens. I gotta slow down. Okay. Or actually, I'll run backwards so that you guys can see it better. So I run, and once again I fly off. So we need to fix that. And first, I'm going to build a new staircase. So let's, how about right over here? This is a good spot. So game object, create other cube. Where is it? Oh, it's underground. That's why. That is not where I wanted it to go. I wanted it to be over here. Alright, that's good enough. Alright, and now I'm going to make this the general shape of a stair. Good enough. And alright, so I'm going to rename this a step, and I'm just going to create a game object, and I'm going to call this stairs case. Okay, and I'm going to set this step as a child of that, just so that I can keep all of these in the same place. So now I'm going to, well, first of all, how do I turn on snapping? That would be very useful right now. Snapping. Do I have to hold down a key to make it snap? Let's see. Yes, I do. Alright, that was too big of a snap. Can I make it a smaller snap? How do I make it a smaller snap? That was too big of a snap. How do I make the snap smaller? Actually, I think I know how. Control Z, Control Z. I believe it is in preferences. Where was it? Was it in here? Snapping. Edit. Oh, snap settings. There we go. Aha! There's a little window for this. Alright, I'm going to set these all to, how about 0.5? And, whoop, didn't want to move it yet. So I'm going to snap. Actually, I'm going to snap it over twice. That way. Okay. Now I'm going to duplicate it again. Snap. Duplicate it again. Snap. And why don't I just drag or grab multiple steps at once, duplicate all of them, and snap. Awesome. Duplicate that again. Snap. I'm holding down command, by the way. It's probably control on a PC, if I had to guess. Alright, and that looks, let's make it just a little longer. Alright, that looks pretty good. And then I'm going to call this top. And I'm going to move it over. And I'm going to make this a long platform, just like I have going on over here. And as you can see, I have all the box colliders still turned on. So, let me show you what happens when we try to walk up the staircase right now. I can tell you one thing, it's going to be very difficult. I'm going to have to do a lot of jumping. This is very tedious. This is not a fun staircase to go up right now. Ah, there we go. And going down it is probably going to be just as bad. Yep. Alright, so first of all, let's see how to fix that. So let me select all of these steps, and I'm going to disable the box collider on all of those. So now we have the box collider disabled, and I'm just going to go ahead and duplicate this right here, and I'm going to call this ramp, and I'm going to rotate it until it is about at the same angle as the stairs. Still need more rotation. I want it to be just, there we go, that's looking good. And let's make it a little longer. Have it go actually into the ground a little bit. And just intersect it at the top up here. It's going under the ground. Alright, so that looks like a pretty good ramp. And now I'm going to go over here and I'm going to turn the renderer off. Alright, now let's give the staircase a try. So where is it? It's over here. Now when I walk up it, it's nice and smooth, but I fly off of it. So that is the main thing that we're going to be fixing today, because it is very, very difficult to use these stairs right now. So I'm going to get rid of that snap thingamajig. Alright, So first of all, why don't I create my stair going up ramp and stair going down, or not ramp, stair going up and stair going down game objects. So I'm going to duplicate that, bring it up, and I'm going to call this stair going up, and I'm going to resize it just big enough so that I know the player will hit it, and I want it to be at the very top of the staircase. And I want to turn the box collider on, the renderer off, and I want to set the box collider to a trigger. And one very, very important thing that I need to point out in order to make this system work is that, first of all, set this to local so that this blue arrow, as you can see up here, blue is Z, we want it to be pointing this direction, so the direction that you want to go after you get to the very top of the staircase. So now let's duplicate it again. So, and we're going to name this one stair going down. And I'm going to rotate it along the y-axis at 180 degrees. And now you can see the blue arrow is pointing in this direction down the stairs. I guess we could even, shouldn't make much of a difference, but we could even point it that way so that it's pointing directly down the stairs. So now we know this is stairs going down. So the reason why I said make sure this says local, because see, if I set it to global, no matter what, it's going to be pointing in this direction. So you want to set it to local so that we know which direction our game object is facing. Alright, now the next thing these things need is some tags. So let's add a tag, and let's see what I named it over here. It was stair going up and stair going down. So stair going up, enter, stair going down. So let's go to the going down one, and let's set that to stair going down. And let's set this one to stair going up. And now I think our game is all set. So now we just need to make the code. So let's go into the player movement script, which is right here. Player movement script. On trigger stay. So let's put it all in here. So if hit trigger dot transform dot tag equals stair going up, and I gotta refer back to my code. No, we don't need brackets. Alright, and now if input dot get button jump, and we want to make sure if that is set to false, and we are moving in the general direction of these stairs. So let's see, if vector 3 dot angle rigid body, but we don't want it capital, we want it lowercase, because we are referencing the rigid body that is attached to the game object that the script is attached to, dot velocity, and then hit trigger dot transform dot forward is smaller than 90. So basically this whole thing right here is if our game object is moving in the same general direction that the stair game object, then let me select it so that I can reference it, is pointing. Whoops, didn't need to move it. Alright, there we go. And then we're going to do if rigid body dot velocity dot y is larger than 0, rigid body dot velocity dot y equal 0. Alright, cool. So that is our stair going up script. So let's give it a shot and see how well it works. So I walk up the stairs and I totally just ramped. Did I do something wrong? Maybe I missed it. I need to make it taller and longer. Alright, now let's give it a shot. And once again I ramped. Oh, I forgot to check the tag. Oh, no, I checked the tag, so if it is stair going up, what did this say? Null reference exception hit trigger dot, there's my problem. Spelled transform wrong. Okay, now let's give it a try. Cool. Alright, walking up the stairs, and boom! Awesome. I didn't fly off, but I flew off that way. We still need to do that. But there is no longer a ramp effect. I just went to the very top of it. It should even work if I'm going backwards, so I'll walk backwards up the stairs. Yep, still worked. Fell off, but it still worked. Alright, now we need to do the stairs going down part. So let's go back into monodevelop. And if hit trigger dot transform dot tag equals stair going down. And then if input, actually I'm going to, I'm just going to copy and paste this whole thing, because it should behave it should be the exact same if statement. I'm going to do rigid body dot add force 0, comma, negative 100, comma, 0. Alright, now let's give that a try. So, I'm walking up the stairs, boom, don't ramp down, so now let's see if I ramp going this way. No, I stuck to the stairs, awesome. So now, we have some fully functional stairs that behave just as stairs should. Awesome. So, that is how to make stairs. Actually, you know what, I'm going to resize that just a tad. I'm also, you know what, I'm going to rotate it somewhere in the middle. I think that should behave the best. So let me give that one more test shot. Walking up, I don't fly off. Walking down, I don't fly off. Awesome. Cool. So now let's actually take a look at the other thing I mentioned, which was over here. I want to put these two lines of code inside of fixed update. So I'm going to find a, alright, here they go, right here. So I'm just going to comment out these lines of code, just in case later I decide that I did want them there, but really I don't. So let's create this function. So function fixed update. Oh, okay. And I'm going to copy and paste it. And then I'm going to just delete everything that says times time.delta time. Times time.delta time. Times time.delta time. Times time.delta time. Alright, looks pretty good. Now, let's start editing the player movement, because I'm pretty sure I'm going to move really, really fast. Yes, I am moving really, really fast right now because we're working with a different timings here. So I'm going to change walk acceleration to, let's start with 300. Then I want walk deceleration. Let's set that to 0.2. And then max walk speed, I'm going to set this to 15. So it's all about just trial and error and just keep on going until it feels right. So this feels pretty good, I think. So you really want to utilize those three variables, which are max walk speed, walk deceleration, and walk acceleration. And from there, you should be able to get something that just feels perfect. One other thing is I should probably lower how high the player jumps. That's pretty unrealistic. And then the last thing I want to change is I want to create a physic material. So physic material, and I'm going to call this player physic material. And I'm going to drag and drop that on top of the player just as if it were a texture material. And as you can see, it's not a component, but it goes into the collider, and where it says material, it says physic material, and as you can see, it highlights it right there. So now let's edit it. So I want to do both types of friction to 0, and then friction combined multiply. So basically, I just made the player really, really slippery, which is fine because we have equations to slow down the player, but it's good because say I walk up at an angle against this wall, I don't snag on it very much. Like, it slows me down a little bit, but it's not enough to be annoying, and it doesn't snag right on the player. And now all of the movement we know is controlled by the code that we have in the script. So this is feeling pretty good. I feel like I have good control over the player. So, yep. That is, I believe now that is everything that I wanted to show you in this episode. So, cool. Until my next episode, I'll see you guys later, and keep making games.